Welcome you, our learner, to today's deep dive. We are jumping right into a pretty staggering April 2026 technical report and press release from 206 Innovation, Inc.
Yeah, it's really something else. They're introducing what they call the Dillon Collatz framework.
Right, and our mission today is to understand their claim that legacy cryptography, so, RSA, AES, and even the NIST post-quantum standards, are all structurally vulnerable to a 256-bit manifold collapse.
Which is just a massive, massive paradigm shift. I mean, for decades, your data's security relied on probabilistic hardness.
Okay, so I was trying to wrap my head around this. Is modern encryption now basically a bank vault that just had its physical hinges geometrically dissolved rather than having its lock picked?
That is a really fantastic analogy, actually, because since the vault's hinges are gone, you aren't really picking the lock anymore.
Right, but how does that lock picking actually work without the hinges? Like, how do they do it?
Well, historically, we treated an algorithm like SHA-256 as this random black box.
Yeah.
But this framework redefines it as a geometric projector.
A geometric projector.
Yeah. It measures inputs against this thing they call a universal ROM, and that ROM is defined by constants like pi, e, and the golden ratio.
Oh, wow.
So, yeah, security has totally shifted from probabilistic hardness to geometric contractibility.
Okay, let's unpack this. If finding a password isn't brute force guessing anymore, is it more like, I don't know, pouring water over a bumpy surface and watching it naturally pool into the only smooth spot?
Yes, exactly. That's a great way to visualize their rigidity leak diagnostic. So, wrong passwords essentially have high curvature.
Like the bumps on the surface.
Right. They're structurally rough. But the correct witness, the actual password, it exhibits zero curvature. It's totally smooth.
So the water just finds it immediately. But wait, how do they filter out all the rough spots so fast?
Well, candidates that exceed a structural roughness threshold of 1.618.
Oh, the golden ratio.
Exactly.
Yeah.
Anything above that hits a rigidity wall and is just instantly discarded. It's mathematically impossible for it to be the right answer.
That's wild. So this happens through that deterministic reduction sequence mentioned in the report.
Yep. The collapse starts at this really diffuse state, like 132,303 candidates.
Okay.
Then they compress it using modular Ricci flow. That drops the candidate pool down to just 611.
And then finally to zero, right? The single localized witness.
You got it. It just flattens out all the non-polynomial noise.
Wait, hold on. Non-polynomial noise. Does this imply what I think it implies? Like P equals NP?
That is the staggering implication here. Finding the needle isn't hard if you can just mathematically dissolve the hay. Computational hardness is basically a geometric illusion now.
So what does this all mean? Does this mean software security is just dead and we have to rely entirely on silicon-level environmental hash gating to protect our data?
I mean, yeah, software alone definitely isn't going to cut it anymore. We need what the report calls the geodesic shield.
The geodesic shield. And that's hardware, right?
Right. It's a defensive paradigm that uses zero-point harmonic collapse to create manifold hard encryption right at the hardware level.
Like the NVIDIA IGX Thor safety island system I saw in the press release.
Exactly. Systems like that now aggressively reject any non-rigid data packets. And they do it in sub-millisecond cycles. We're talking less than 1.2 microseconds.
So it literally shuts the gate before the geometry attack can even calculate.
Exactly. We're entirely moving beyond those old inherited hardness narratives into, well, a reality governed by the manifold rigid recovery operator.
That is just, it's mind-blowing to think about.
It really is.
Well, we've got a final provocative thought for you, our learner, to ponder. If all current digital security was based on a mathematical illusion that was just shattered, well, what guarantees that this new manifold hard geometry won't also be bypassed by tomorrow's next mathematical breakthrough?